Hey everybody, how's it going? This is Boneyard Labs, and I am out on the road today, but I wanted to cover something for you. I found out a way, an easy and free way, how to increase the air velocity or air volume that you're passing through your Kaspa miners or any ASIC miners. Really super simple, and I wanted to share it with you. So this was my starting air velocity out of my exhaust side of my miner. So this is in feet per minute, and I got the max speed at 1,142 feet per minute. I got it up to 1,280 feet per minute. So it's about a 12% increase, which is pretty significant for a free mod. All right, so let me show you what I did. So step one, I took the miner down off the wall, and this mesh was basically my concern, right? So if you take the surface area of that mesh and how much of that surface area is interfering with the airflow into those hash boards, you're obviously going to come to the conclusion that I did, in that it's blocking quite a bit of the opening. Okay, so my solution, my favorite Nipex pliers. All right, essentially all I did, I started snipping each one of these locations here. Just started snipping away at it. I mean, it's just soft aluminum. It'll come right off with relative ease until it looks like that, right? You want to leave the perimeter alone, and you want to leave this center section alone because that kind of stabilizes the hash boards a little bit. But more important, or also equally as important, you got these holes here that you're going to use to mount the ducting back onto the box. And so the reason I decided to do this was because I looked up, I was trying to gain some knowledge on the effects of the grill patterns, right, and how it interferes with the airflow. Okay, and I found this, and this guy did this test with various different types of fan guards, okay? And of course noise was a factor, depending on what kind, of course, because they start to vibrate when you get high enough velocity through them. But also what I was interested in is the airflow, because that will dictate how well I can cool off my chips, right? So if you have no grill, intake side, 100%, of course, you're getting 100% all throughout. And then you go to wire grill, and you get very little loss. And then you go to stamp circles, and you get a little more loss and whatnot. But if you come down to honeycomb, you got right here, you got intake side, exhaust side. So you see from the control, which is no grill, down to the honeycomb style, shows a 9%, an 8 to 9% reduction by using these honeycombs. Now, I wasn't too concerned about airflow straightening either, because of the fact that because I'm using an AC Infinity 8-inch fan, the airflow is already swirling like crazy in here, and it's going wherever it's going to go. So it wasn't really doing a great job, and I will show you that on a future video when I'm done doing some testing on how to further straighten out that air and provide a more uniform flow into the box, because right now, I'll give you a little hint, it really sucks. So I'm going to fix that later on in another video, and I'll show you guys how to do that too. But my result for this was, I actually also dropped about 3 to 4 C on each chip after doing this cutaway, and I only did it on the inlet side. I didn't really bother to do it on the outlet side, mainly because I was pressed on time. But you could perhaps get a little more flow if you cut the other side as well. So like I said, I got 12% airflow increase from just cutting out this honeycomb. And if you're worried about rigidity issues, that's not really a concern, because there's all these bends that add some rigidity to it on the perimeter, as well as the fact that you're going to be bolting your duct right back onto here, which is going to make it more rigid anyways. So there's no loss in rigidity really, and if it is, it's super negligible. Whether or not it's a bad thing for potential ingestion of large foreign objects, that is something you'll have to decide whether that's a risk you want to take or not. I personally don't have a risk of it because the inlet is in a safe place where nothing's really going to fall into it or go into it. So very, very low concern for me. And the last thing I wanted to show you is my chip set temperatures. So if you could see off to the right over here, you got chip number and temperature, and this is before cutting the mesh and after cutting the mesh. So you could see pretty much all across the board. You could see like chip 14 went from 76 to 73, 76 to 73, 76 74, 77 74. So basically, as you go down the line here, all of these chips dropped a couple of degrees. And even this one, there was the most drop I got was actually like 79 to 69, or no, 76 to 69. So I mean, these ones got a good reduction across the board for the most part. Yeah, 3 or 4 3 or 4 C on a lot of them. And yes, the ambient temperatures were the same. It was about 68 degrees in there when I did this on both instances, and I let them run for about 15 minutes to make sure that they were all warmed up to their nominal operating temperatures. So yeah, I mean, the proof is in the pudding here. It's in the numbers. That really is a nice improvement for something that took very little time to do, very little downtime. And I got some temp improvements as well as airflow, and it worked for me. So take what you will from this and decide if you want to do it yourself. Get some improvements. Let me know in the comments if you did it and if it worked for you and what your results were. Until then, happy mining.